Now turn comes for question number 81. It says the maximum number of the orbitals that can be identified by the following quantum numbers in an atom is. So we have n value which is 5, L value which is 2, M value which is -1. It's given in the question. Now you have to just find out that the maximum number of orbitals associated with it. Okay. So if I'm just looking at this is principal quantum number it is. Now L value, if you just look at, this is azimuthal quantum number, right? And for the value of 2 of azimuthal quantum number, M value, that is the magnetic quantum number, you know. This magnetic quantum number can be, M value can be -2, -1, 0, +1, +2. And which value we are just talking about? We're talking about this -1 value, and with this only one orbital is associated, you know, one orbital is associated with it, and in which the 2 electrons can exist, right? But they're not talking about electron, they're talking about the maximum number of orbitals only, right? So where the maximum number of orbitals given? One only, this number of orbital, and it is given here in option 4, so that you can choose. Now next question is question number 82. Suppose the elements X and Y combine to form two compounds XY and XY3. So two compounds it is forming. If 0.2 mole of XY weigh 24 gram and 0.1 mole of XY3 weigh 16 gram, it means the different quantities, different moles are given and their weight is also given. With the help of that, you can easily find out the mass of 1 mole. And what is the mass of 1 mole? That is the molar mass, right? Now, then atomic weight of X and Y respectively are. So the two things are given. One is the two different compounds XY and XY3, right? This is one thing which is given. Another thing which is given here is the weights. 0.2 mole of XY. It's weighing 24 gram. And as I've already told you, if you can calculate the mass of 1 mole, that would be the molar mass. So 1 mole of XY, I'm applying the simple unitary method once again, right? So 24 divided by 0.2, and that will be giving me 240 by 2, it means 120 gram. So this would be the molar mass which is associated with XY. So I'm writing here the molar mass of this, I've just calculated, this is 120 gram per mole. Getting it? Now same thing I'm going to do with XY3 as well. So as per the question, 0.1 mole of XY3 is giving me 16 gram mass, right? So what about 1 mole of XY3? Very true. 16 divided by 0.1, right? It is 160 gram. So molar mass for these two, 160 gram per mole. For both of them we have calculated. Now just recall how we calculate the molecular mass, right? What we do, we just check what is the atomic weights of the substances there, how many atoms are there, and on the basis of that we calculate. The same thing I'm going to do with here also, right? So I'm just assuming that X is the element, Y is the element, and their atomic masses are X and Y itself, right? With the help of these, I can make an equation like the mass of X, atomic mass of X plus atomic mass of Y will give me the molecular mass of this species, right? And already we know the molar mass, so molecular mass would be 120 U. Getting it? So this is my first expression or the first equation that I have. Now second, atomic mass we have already assumed X for X plus for Y it was Y, but there are 3 atoms, so 3Y. The sum would be equal to molecular mass. So this can be taken as 160, the second equation I have, right? So now what I'm going to do, I'm just going to subtract equation 1 from equation 2, right? So equation 2 I have, this is X plus 3Y equals to 160, X plus Y equals to 120. If you just solve this, I'm just subtracting. So 2Y is equal to 40. So what would be the value of Y? That would be 20 only, right? So what is the value of x? This comes out to be, yes, 120 minus 20. So it is 100. Clear? So x 100, y 20. In which option it is given? X as 100 and y as 20. You are getting it right. It is correctly given in option 4. So if you have chosen this, your answer is right. Now, the turn is to take question number 83. If the density of the methanol is 0.9 gram per milliliter. So, question is based on density and then volume of methanol needed for making 2 liter of 0.5 molar solution is. It means the solute methanol we have, its density is given. Now you need to just find out its volume that is used for the preparation of its 0.5 molar solution with the volume 2 liter. Okay. So molarity you have, that is 0.5 molar, right? If I just multiply volume in this molarity, then I can get the number of moles, right? Moles I got. So moles 1. So these are the moles of methanol, right? In one step I did this. Moles I have. Now density of this methanol is given. From the mole I can easily find out the mass of methanol as well. How? Because everybody is aware that moles is equals to given mass by molar mass of the species, right? So for the molar mass I'm using double M, right? Now, so in this way the weight would be equal to moles, that is 1. And what about the molar mass of methanol? Formula you know, CH3OH, just calculate 12 plus 3 plus 16 plus 1. So it comes out to be 32, right? 32 gram per mole. So the weight of methanol is 32 gram. Getting it? Weight we have. Now, with the help of this, you need to find out the volume. Density you have. Density is mass per unit volume, right? Density of methanol is given 0.9 gram per ml, isn't it? Okay. Now, mass 32. This is also given, divided by volume. So, how much would be the volume? Volume is equal to absolutely 32 by 0.9, right? To solve this. If you solve this, you will find that this value comes out to be nearly 35.6 ml, because the volume in the density was given in milliliter, so this volume is also in milliliter, right? So the right answer is correctly given there in option 1. That's your answer. Now the turn comes for question number 84. Angular momentum of an electron in third stationary orbit of hydrogen atom will be. So angular momentum, mvr is equals to nh by 2 pi. This formula we take, right? Now in this formula, this is the angular momentum. No need to go for mass, velocity or the radius of the shell. You have to just go for the angular momentum entirely in the third stationary state. It means n value is 3. Clearly given in the question, right? And this is hydrogen atom. For this, you need to calculate. Now, answer is not given as 3h by 2 pi. It's not given this way. So, answer is given in h cross value, right? So, in terms of h cross, you need to find out. I hope you are aware that this is h cross, right? So, angular momentum is equal to 3h cross for this question. And yes, it's given in the option number 2. That you can easily choose as your right answer. Okay, done with this, and turn comes for question number 85. Energy required to excite the electron in hydrogen atom from first orbit to second orbit. So you are just initially it was there in first orbit and it gets excited to the next orbit, and final would be the second one. Clear? And you need to find out that total energy required. It means initially it would have even energy and later it becomes E2 energy. So change in energy or the energy required is equal to 2.18 into 10 raised to the power minus 19 into 1 by Ni square. I hope you know this formula. Ni square minus 1 by n final square, right? Okay, so initially the n value is 1 because it is excited from the lower energy level to higher energy level, this way, right? To solve this, minus 19, 1 minus 1 by 4. So this 1 minus 1 by 4, 3 by 4 it would be. Solve this in your own way. 3 by 4, and finally the answer you will be getting, it would be 1.6 into 10 raised to the power minus 18 joule, right? So you have to just go for the final answer, which is given here in the option number 1.